Hello. So we're doing Aqueous Solutions 2 today. Let me get my things out. Alright. Aqueous Solutions 2. Alright. We can start with the first question. And here it says 15 grams piece of zinc is added to a beaker containing dilute hydrochloric acid and effervescence occurs. Okay, so after all these reactions have ceased, okay, and it gave us this equation. So zinc plus 2 hydrochloric acid equals zinc chloride plus hydrogen gas. So, and then say after all reactions has ceased, the piece of zinc was washed, dried, and found to have a mass of 2 grams. So went from 15 grams to 2 grams of zinc. And deduce from these results that what is the number of moles of hydrochloric acid in the beaker? Okay, as we can see from the reaction, so the zinc is gone. Okay, the zinc is gone. It went from 15 to 2 grams. Where did the extra zinc go? It went into zinc chloride. I missed the 2. That's where it went. So we need to know how many. Now we know the mass. So the mass of the zinc in zinc chloride is 15 take 2, which is 13 grams. And now, because it's asking for the number of moles, we want to convert that to the moles, which means that is just 13 mass over molar mass equals 13 over zinc. Zinc is 6538 equals, let's see, 13 divided by 65.38, 0.198837565 moles. Okay, that's the number of moles of zinc. Now I have to do the moles mass of the number of moles of the HCl, because that's what's asking the question. Hydrochloric acid equals number of moles for zinc. And look, this is 2, this is 1, which means that to get this to equal to this, we need this 2 times 2. So the 2 becomes 1 and they equal. Alright, so we need a 2 in front. That does not look like 2. Okay, which equals to 0.199 times 2. We're writing simplified because I'm not writing down the whole thing again. So that's 0.39767513 moles, and that's 0.398 moles of hydrochloric acid, and that's it for part A. And part B asks the mass of zinc chloride which can be removed from the solution in the beaker. So they want us to find the mass of zinc chloride. So first we know the moles of zinc chloride, which is the moles of zinc, as the ratio in the equation is 1 to, so the 1 to 1. So that means that just equals 0.199 moles, and then the mass of zinc chloride equals to mass over molar mass, which equals to 0.199 over molar mass, which is zinc is 65.38. Yep. Plus chloride, which is 35.45 times 2, and that equals to divided by 65.38 plus 35.45 times 2. That equals to 0.00145903701 that grams. Wait. Oh, we're finding the mass, not finding the mass, not the moles. So the equation is not this. It should be number of moles times the mass. So these two should be timed together. Okay, that's not good. Okay, they should be timed by each other. And that should give us instead of this weird number, which is probably wrong, it's 27.09758 grams, 27.1 grams. Okay, now part C says it wants the volume of hydrogen gas produced by the reaction at standard temperature and pressure. Okay, so normally we know our equation like 22.71 like that, but now we have the moles, we want to find the volume, so we rearrange it to get volume equals 22.71 times moles. So the volume for H2 will be 22.71 times 0.199, which equals to, let's find that, times 22.71, as that's the equation, it's 4.5156, which equals to 4.52 liters. That is indeed correct. All right, that's it for this question. Now we'll move on to the second question, where it says, let's write that. Second question. So it says a 0.482 gram sample of alloy of silver and copper is dissolved in nitric acid. The resulting solution requires 41.5 milliliters of 0.0993 moles per liter sodium chloride solution for complete precipitation of silver ions. Calculate the percentage of silver in the alloy. Okay, so this is obviously the last step because that's the total amount of mass. So we first have to find the mass of only silver. So how can we do that? So what we're going to do is, normally we would just use an equation, but look at the units. This is moles per liter. This is liters. So what we can just do is 0.0993 is obviously equal to moles over liters. That means the number of moles of what is it? Sodium chloride. NaCl, yeah. NaCl, yep. Equals to 41.5 divided by 1,000, because it's in milliliters, times 0.0993 is as that's what thing says, yeah. So we found out that this equals moles per liters, and if we move the liters to this side, it will obviously become a number of moles. So that is equal to 41.5 divided by 1,000 times 0.0993. I think that's right. Yep. That becomes 0.00412095. That's moles. And because we know the number of moles now of sodium chloride, it says the complete precipitation of silver ions. Silver ions will precipitate with chloride to form silver chloride, the number of moles of silver chloride were equal to the number of moles of NaCl, which equals 0.0041295 moles. And then we want to find the mass of, because the moles of this, so the number of moles of actual silver in this, it will be equal to the number of moles of the total, which is equal to 0.0041295 moles. And now we can find the mass of silver on its own, which equals to, well, moles times molar mass, which equals to 0.0041295 times Ag. Let's see. Let me find Ag is 107.87. 107.87. That equals to 0.0. Oh, I misclicked. It is equal to 0.4445268765 grams. And now we want to know the percentage, as the question is asking for the percentage of silver in the alloy. Percentage equals to mass of Ag over mass of alloy times 100 equals to 0.4445268763 over, let's see where it went here, 0.482, yeah, and times 100 equals to divided by 0.4482, we get 92.22549305, 92.2% of silver in this alloy. Alright, that's it for the questions. Bye bye.